in Africa, the central part of Africa is the one that receives a lot of rain. And if you look at the red part, the red highlighted part is the one where the extent of soil acidification is so high compared to, say, North Africa and somewhere between Central Africa and Southern Africa. Now, it's going to take millions and if not billions to get these soils back to productive states so that we can be at the level of America or the Europeans. At world level, if you look again, you'll see the part of the USA and parts of Europe where agriculture has been going on for many, many years, even before South Africa. These guys have been using fertilizer for hundreds of years, okay? But if you look at what is happening, the western part of Europe, because they've got the finances and the knowledge to apply lime, their soil is not as acidic as Eastern Europe, where they don't have money. Now, nitrogen is also a greenhouse gas. Fertilizers contribute about 30% of total world ammonia emission. Other contributors is through livestock, and this may include nitric and nitrous oxide. Now, I said even though ammonia contributes about 1% of greenhouse gases, it is still a concern, because if we can lower the amount of ammonia and other nitrogen-based gases in our atmosphere, it will be our humble contribution from the fertilizer industry. That graph is from the UK. If you look, the contribution by nitrates, N2O, it was 40%, and from manure, it was about 4%. Now, that 40% is of concern, because if we've got alternatives that we can use, then why not use them and avoid using nitrogen-based fertilizers? Phosphorus. This is also an element of concern. We often think about oil and water as one of the things that are going to cause the next world war. From my point of view, I think phosphorus is one of the most important elements in South Africa and in the world, because it's not available, and because of it, we cannot produce enough crops. In South Africa, we've got deficiency of phosphorus in most of our soils, but the deficiency is caused by the availability of metals in the soil. If you look at red soils in particular, you'll know that you're likely to have phosphorus deficiency in the soils, because the phosphorus is strongly bonded to metals like manganese, iron, and zinc. Now, low soil pH, because it makes because low soil pH, it releases the metals. Then the metals get bonded to the phosphorus, making the phosphorus unavailable in the soils. I studied in Australia when I was doing my master's. One of my professors told us that there's a certain plot where they were doing research. They applied tons and tons of phosphorus, and about 50 years ago. But even today, the phosphorus that they applied into that soil is not available, because they did not fix the soil pH before then. And the phosphorus is there in the soil, but is strongly fixed by other metals. Now, unlike nitrogen, that is, I can say, is available. I don't see issues with phosphorus in the next 100 years, but phosphate, which is mined from rock phosphate, I foresee a problem in the future. It's not a problem of if, it's a problem of when is it going to be depleted. And like I said, it's mined from rock phosphate and it's generally unreactive in soils. But to make it reactive, they treat it with hydrochloric acid to form superphosphate. It's either going to be single superphosphate or triple superphosphate. And from there, they can make other forms of available phosphorus. And another form of phosphorus that might be available to plants is organic phosphorus that is usually released when plants and animal matter decay in soils. Now, I wanted to show you the relationship between phosphorus and crop production. Now, on the left is soybean. I don't know if it's visible. On the left is soybean, and then we've got corn, is an American for maize, and then wheat. Now, if you increase phosphorus exponentially, you increase the yield of corn and wheat and soybean, and that trend is more or less the same for all the other crops. Now, the phosphorus that is there is extractable phosphorus and is extracted in Bray. I hope it's Bray 1 or Bray 2, but it's in ppm. So, but what I'm basically trying to say is that the more available phosphorus you make in the soil, the more yield we're going to get and the more we're going to be able to feed the world, and South Africa in particular. Now, that is a hockey stick graph. If you look at it again from 1910, the use of phosphorus was less, but as time goes by, the use of phosphorus increases. And it's a no-brainer that at some point in time, because this is not a renewable resource, where we're going to get over the tipping point. Now, world phosphorus resources, who controls it the more? Morocco has got about 38% of reserves. I don't know, Prof is going to have a problem with me saying reserves. And China has got 27%, the USA 8%. South Africa, we've got 10% of world phosphorus reserves. But most of it comes from Fosco in Phalaborwa, in Limpopo. And the challenge with South Africa is that we export most of our phosphorus. A few years back, China increased its export tariffs on phosphorus up to 200%. So that should tell you that we also need to take care of our precious natural resources. Who knows, maybe in future we may use them as a bargaining chip. Now, over application of phosphorus may lead to phosphorus poisoning in soils. Once more than optimum levels is reached, you cannot grow a lot of crops, or you cannot grow crops economically on those kind of soil. But soluble forms too, they can lead to groundwater and reduce the quality of water. And it may also lead to, the soluble form may also accumulate in water bodies, in lakes, in rivers, and in dams, and also lead to eutrophication, just like nitrogen. Now, that is a place where I grew up when I was young. That dam is Hartebees Dam. When I was growing up in the early 90s, it used to be a beautiful place. I went there a few months back. I didn't like what I saw. That is the result of eutrophication, but that I cannot attribute it only to fertilizers. It's fertilizers and raw sewage going through the rivers, and which end up in the dam, which is the Hartebees Dam. And the combination of another plant called the hyacinth plant growing in the RTPS stem. You can imagine what that does to the value of the properties that surrounds there, and what it does to the value of the crops that people grow downstream. Now, the last one that I'm going to talk about, mineral element in agriculture, not in agriculture, the one of the three macronutrients is potassium. This one is fairly abundant in the soils. Our earth crust is got about 2.3%, but is not evenly distributed throughout the world. There are other countries that have got more, and others have got less, and South Africa has got none. And on average, every time you harvest a crop, you are removing about 300 kg per hectare of it, which necessitates the need for fertilization. Remember that farming is another form of mining. Every time you remove a crop, you remove mineral elements in the soil, and that necessitates the need for fertilization. Potassium, just more like phosphorus, its use in the world. It started being very less in the early 1900s, and it just skyrocketed in the 1970s. But the interesting part is that the price of potassium or potash, it went up in 2008 during the world economic meltdown, and it was about 3 times or 4 times the price of nitrogen and phosphorus, which caused the sharp increase in the cost of food in the world. Now, who has got the largest potash reserves? Canada has got the largest, Russia, Belarus, Brazil, and the others, they've got smaller reserves of potash. Now, in conclusion, I would like to highlight the following, that it is apparent that the minerals that we are having in the world, they're finite. As long as our population keeps growing, and we are going to need to use more fertilizers to increase food production per hectare or per square meter, instead, because land is not available. So in South Africa, most farmers, because they don't do crop rotation, they use more fertilizers, even more. Now, the question is not if, but when will they be depleted? Now, we have to start preparing ourselves that to get alternative sources of these resources, or at least get other forms of farming that can make these resources or tap these resources in the soils. Now, to continue food production in a sustainable way, we need to relook how we apply fertilizers. One of the suggestions that I had was that we should reuse human waste, or what is called biosolid, and because biosolid is already being used in the USA in large quantities. And the other one is the reuse of municipal solid waste, because 80% of municipal solid waste that goes into landfills is actually organic material that can be used into nutrient cycling. And we must also have a look at the use of organic fertilizers, especially for smaller operations. If you've got 1 hectare, less than 5 hectares, we can produce using organic fertilizers. And we also need to strengthen our regulations to monitor the use of nitrogen fertilizers on farm, levels like they do in the USA and in Europe. What they do nitrogen budgeting. Farmers don't just go and dump their fertilizers in their farms. There's a budget, there must be an agronomist that come and do soil analysis and what they're going to produce, and how much nitrogen, how much phosphorus, and how much potassium they're going to use, so that they don't apply excess fertilizers which might end up contaminating the environment. Now, we must explore the use of animal manure, especially for animals that are produced in feedlots. We must look at rotating cereal and legume crops. Legumes, like I said, they give us the free form of nitrogen other than using the Haber-Bosch process. And we have to protect the soils from erosion, and we have to embrace nature farming and look at other forms of farming like zero tillage that will improve soil organic matter. Thank you.